Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone and welcome to my video. First of all, thank you for watching this video. My name is Endang Prasetyaningsih. I'm a lecturer at Industrial Engineering Program Study, Engineering Faculty, Universitas Islam Bandung, West Java, Indonesia. At this opportunity, I would like to present my research which is submitted to the Science and Technology Research Symposium or SiRes 2020. My research entitled is Conceptual Model of System Dynamics for Increasing Catfish Productivity Using Recirculation Aquaculture Systems. This presentation is divided into 4 sections. Firstly is the introduction. Secondly, the research method. Thirdly, result and discussion. And finally, the conclusions. Let's start with the introduction. The introduction describes the motivation of this research. We find that there are high demand of catfish at Bandung City. We take a case study at Cirayam Market at Bandung City. The Cirayam Market needs catfish every 2 days from Paguyuban Lele Baraya. But Paguyuban Lele Baraya at Rancamanyar District, Bandung, only deliver every 2 weeks due to the limited catfish production. This problem encourages catfish farmers at Rancamanyar to increase catfish productivity. However, the farming lands are limited and very expensive. So, the farmer want to increasing productivity by developing technology, that is, converting technology at catfish seed level from biofloc technology to Resirculation Aquaculture System or RES. There are some benefits by converting biofloc into RES. When we using RES, it will reduce water usage, increase efficiency nutrient, improve waste management. It will produce bigger catfish and reduce land usage. Converting technology at catfish seed level from biofloc technology into RES will increase productivity, but on the other side, the converting need require investment that can be get from debt. The debt increase debt repayment and it will decrease income. So there is a trade-off between increased productivity and decreased income. The problem is how to increase productivity, but the companies still get profit. The phenomenon of developing catfish farming includes conversion technology, productivity, production costs, income, and profit. There are many interrelated variables, so we choose system dynamics to describe the phenomenon of catfish farming. The research method. We use descriptive analytics to develop a conceptual model of catfish farming. To collect data, we use observation and interviews. The output of this research is causal loop diagram or CLD of catfish farming. This is the result and discussion. CLD of the current condition submodel begins from the selling catfish on the Bandung local market. This figure describes the catfish business loop with sales to the Bandung local market, where the availability of the catfish in the Bandung local market has positive implications for the number of products sold and income. If the profit of catfish farm increases, the farmer desire to produce catfish increases as well. It can be fulfilled by adding ponds for catfish farming. Increasing the number of ponds will increase the requirement of catfish seeds. For all, the initial loop for providing reinforcing properties are 1. Increasing catfish seeds require new ponds addition so that increasing the number of total ponds. Meanwhile, increasing number of total ponds will increase catfish seed production. Consequently, the catfish seed requirement will decrease. This creates a new balancing loop B1. The farmers desire to increase catfish production by adding new ponds have constraints due to the limitation of the area. Therefore, the catfish seed ponds that already use biofloc technology will be developed with RES technology. The conversion of some biofloc pond into RES technology changes the existing B1 loop. Adding RES technology into existing biofloc technology requires investment which is obtained from debt. It has negative implication for income due to the debt repayment. The application of RES technology also raises electricity costs and maintenance costs, which have positive implication for the production costs. So, the increasing costs have positive implication for the total production cost, but it has negative implication for the income of catfish farmer. This addition of this variable forms a new balancing loop, LB2. Catfish demand is influenced by the catfish consumption per capita of population, and the increase of the population will have positive implication for the catfish demand at the Bandung local market. Meanwhile, the population is influenced by the population growth rate. This population growth creates a reinforcing loop, R2. This is the final CLD of catfish farming business. Discussion. The CLD of catfish farming consists of 5 elements that are demand, catfish production, income, profit, and the conversion of pond with biofloc technology into RES technology. The CLD have 2 balancing loops, income loop B1 and production loop B2. And the CLD have 2 reinforcing loops. There are population growth R2 and sales growth R1. The developed CLD should be verified first by using historical data about the catfish farming business, and then general equations and stock flow diagram should be constructed. If the developed CLD can describe the existing catfish farming business, it can be used to predict the development and sustainability of the business. Conclusions. The conceptual model of catfish farming business has 2 balancing loops and 2 reinforcing loops, which consists of 5 elements. The increasing of catfish productivity with RES technology is expected to increase income. The further research is to verify the conceptual model using historical data and construct the stock flow diagram. At this opportunity, we like to thank you to the Research and Community Service of Universitas Islam Bandung for the research grant to support this research. Thank you everyone for watching my video. Assalamualaikum warahmatullahi wabarakatuh.